Hello, this lesson is going to look at getting zeros, or the x-intercepts. Got that on there, which we also call the solutions and roots. So if we had a 0 equals ax squared plus bx plus c, we'd be talking about the solutions and roots. I like to give all the different names for that each time I mention it, because x-intercepts, zeros, solutions, roots all mean practically the same thing, just depending on what situation you're working with, as we mentioned before. So we recently looked at, in the last lesson, we looked at multiplying out binomials, and I'll remind you of that in this question right here, or this section right here. So finding zeros from factored form. So factored form is this right here, where we have the x plus or minus a number. So this one here, the y equals x plus 2 and x minus 3. Okay, that's factored form. It's of a quadratic, and we know it's a quadratic from our previous recent work here, where the x multiplies onto both, giving you an x times an x squared. An x times a -3 is a -3x, and then the 2 multiplies onto both as well, giving us a 2x and a -6. And so you collect like terms, you have your x squared, you have your 2x terms. So there's your quadratic, right? So what you've seen recently was that this quadratic, there's some things we know. We know like how vertically stretched it is, in which case it's the same shape as the original. We know it opens up, right? So let's say its original shape opens up. Other than that, there's not a lot we can tell, other than I guess we know the y-intercept, right? So the y-intercept equals -6. And other than that, we found before, we can't really tell much else about the thing. So what we're going to look at then is this new form of it, which clearly is this x plus 2 and x minus 3, since the reverse process would lead to that, right? So that's something we're going to learn soon. So if we're switching from this form to this form, we're going to see that later. It's called factoring. But I'll tackle that when the time comes. So this is if we're given the equation in factored form. We'll see how useful that is. And then, of course, it says here, we'll learn how to convert to that form, which is factoring. All right, so our process here to find zeros, just like in grade 9, you'd set the y equal to 0. We're looking for the zeros, right? We're looking for where it crosses the x-axis. So this graph here illustrates the idea of it. I think it's the same graph and everything. So to find the x-intercepts, or the zeros, you'd set the y value equal to 0, just like normal. And those are the spots we're interested in, right? So when I put it as x-intercepts, it reminds you of the same as grade 9. For equation of a line, to find the y-intercept, it's set the x to 0. Okay, so we do that. That looks like this right here. We'll set the y value to 0. And then the logic is that you set each one of those to be 0. Basically you say, okay, this one's 0 or this one is 0, and you work towards the answers you get from those, right? And the logic, of course, there that's saying down here is that either of these brackets are 0. As a result, then the overall answer is going to be 0. Because 0 times anything is 0, right? So if we look, we have the result from this is we have the x plus 2 is 0 and the x minus 3 is 0, right? So what we do is we just solve for x in both of them. Okay, so just going here to there, we're just solving for x. I think that's what number 3 is there. Check in a sec here. Right, so that's solve for x from each of those factors. So if we take away 2 from both sides and we add 3 to both sides, each of those gets solved out for zeros of -2 and 3. Okay, so again, just to emphasize here, from the standard form, we have no idea what the zeros are, right? From the factored form, you can tell they're -2 and 3. well, you can get it easily from the factored form. Plus, we're going to look on the next page about how you can tell what they are. So, spoiler alert here. On the next page, we're just going to point out that, positive 2 leads to a negative 2, and negative 3 leads to a positive 3. You can tell it's just the opposite sign. Okay, so that's what we end up doing. So here's another example. We're going to determine the zeros or the x-intercepts. So let's put here x-intercepts question mark. In other words, there's your instructions. And so we're going to set y equal to 0. We're going to realize that either of those things have to be 0 to give your answers. So an x minus 7 is 0, and an x plus 11 is 0. So adding 7 to both sides gives us an answer of x equals 7, and subtracting 11 gives us an answer of x equals negative 11. So just like before, if you go right from the original numbers, it's just the opposite signs. Right, we could jump right from x minus 7 to say, oh, it's plus 7. Similar to what we saw before with the horizontal shift stuff backwards. Right, so many notice of course, the roots are just the opposite sign. Everybody should notice, really, but it's just the opposite sign. So from this one, we could jump right to saying, oh, it's going to be a minus 2 and a plus 3. Okay. Similarly here, b of 0, of course, is going to make everything 0. And then b plus 2 needs to be 0. So that's when we could jump right to a negative 2, wherever I have it here, right there. Right, we could have just jumped right to negative 2. Right, but I went and did it the full way. B is 0 or b plus 2 is 0. Take away 2 from both sides, and so on. Those are your zeros. Right? So yeah, jumping to the answer without any work is nice, but in harder cases, you might need a little more work. Right? It's easy to tell from this one that one of the zeros is negative 4. Right? So there it is, negative 4. Obviously, that comes from x plus 4 equals 0, and you solve out by subtracting 4 from both sides. Right? The other one, though, what value would you put in for x to make that stuff, this bracket, be 0? Right? In order to get 0, what's x? And that's a little harder to guess. But if you know the process, then you can actually solve for it pretty easily. Right? And of course, the process is to say, okay, well, I'm missing a line in this file. That down. So we have, the line I'm missing is the starting one here, 3x minus 7 equals 0. And so then we're going to add 7 to both sides and end up with 3x equals 7. And then we have to divide both sides by 3 to solve, like just regular solving steps, right? So again, just like normal, solve for x. Just solving equations. So I have a reminder there. Like you've looked at solving equations in previous courses. Obviously, it's yet another time when we need to use our ability to solve equations to get answers. Okay, so the zeros are negative 4 and 7/3. Okay. So that is all of that. So that's it, basically. In your handout sheet or your practice sheet, all of these are ready to go, right? Where you can say, okay, well, what are the zeros? So, for this one, for example, I'll do this one with you just because it's a bit of a weird thing here. But you'd want to say 0 equals the w, like set it equal to 0. And then you'd say, okay, well, if that's 0, or if this is 0. In other words, that w equals 0 is pretty obvious. This one's a little weirder. 20 minus w equals 0. Thinking about it, obviously, if you put a 20 in for w, it's going to be 0, right? So the answer is 20. But mathematically, you get it by adding w to both sides. Would be the slickest or quickest way of doing it. You'd have 20 equals w. W equals 20, in other words. Okay? So you have zeros of 20 and 0. In the pictures, obviously, you just be like, it says, what are the zeros? Well, you got a 0 there, 0 there. Just pick the numbers out, 5 and 30. So it's just basically making sure you understand what they mean and so on. Yeah, and then matching each graph. Something to watch for, the positive or negative creeps in here. So when you have the x number being a negative, overall this is going to be a negative x squared one. And so this one, notice that one was going to open down. Okay, whereas the first one was like positive x's. So it's a positive x squared and stuff. And so it's going to open up. So I just thought I'd mention that because I know that could be a little bit of a trick. So when you're trying to match them, you can kind of tell which ones open up or down based on whether the x's are both positive, in which case opens up, or if one's positive, one's negative, in which case the overall is negative x squared, so it opens down. Right? There we go. That's all for now.